DevOps. The term DevOps is becoming more popular among project managers and professionals in the world of IT. So, what is DevOps? Simply put, DevOps is a culture that incorporates a mindset of tight, synchronous collaboration between the developers in a company or business unit and the operations team within that same company. It is a collaboration that results in a fruitful partnership between development and operations to deliver continuous value of features, products, improvements, bug fixes, and other value items to the customer. So welcome to the conversation of DevOps. This is not yet featured on a lot of professional exams, but the word DevOps is permeating industry. Let's talk about the origins of DevOps. The term DevOps was introduced somewhere between 2007 and 2009 by Patrick Dubois, Gene Kim, and John Willis, combining the terms development, dev, and operations, ops. It has catalyzed a movement, a mindset, a culture that advocates the collaboration of developers and operations within a company, a business unit, a team. The key word is customer and value. As a result, we can see a tight association of DevOps and Agile. After all, in Agile, our main goal is to deliver valuable software or product, if you will, to the customer early and continuously. It could be said that the word DevOps puts emphasis on aspects that were already inherent in Agile, but are now on some sort of hyperdrive and hyper focus. We can therefore say Agile frameworks such as Scrum, XP, TDD, and other Agile methodologies and practices enable teams better practice this concept of frequent delivery of value through features, products, bug fixes, and other initiatives. Think about it like this. We become more intentional and more emphatic about the importance of CI and CD. In other words, continuous integration and continuous delivery. The motivations for what has become modern DevOps and standard DevOps practices, such as automated build and test, really originated in the Agile world, which dates to the early 90s and formally to when the Agile Manifesto was put on the map in 2001. Agile teams using methods such as XP, I hate to say it, but couldn't satisfy the customer through early and continuous delivery of valuable product unless they brought in the idea of operations and infrastructure responsibilities associated with the applications, many of which they automated. Because Scrum emerged as the dominant Agile framework in the early 2000s, and it, let's be honest, omitted the engineering practices that were part of many Agile teams, the movement to automate operations and infrastructure functions splintered from Agile and expanded to what has become modern DevOps. Do I begrudge Scrum for that? Absolutely not. Scrum has its good points, but there's a point to which you get where you're heavily in development and operations, and the mantras from Scrum need some additional tailoring up. And this is where DevOps comes in. So we could say DevOps methods combine both development and operations. Prior to DevOps, a typical Agile team would have been responsible for the software from requirement to deployment, with an operations team being responsible for the support of the software after the deployment. But DevOps reduces that barrier. This is all about collaboration. It reduces the barrier between development and operations by combining them. One team, one family, thus delivering software quickly and ensuring its high quality by using the same team. The rationale is that if the developers are also responsible for support, then they won't toss stuff over the wall. Let's be honest, when stuff comes back to bite you in technical debt, you're not going to like that. So you're going to wake up, smell the coffee, and work the best way you can in development, being mindful that it's going to come back to bite you in operations. So we could say the developers have more of an incentive to create reliable code. So all that refactoring will pay off. Now, the PMI have a brilliant illustration of this at the link at pmi.org. I'm going to put the link below. But what this shows you is what DevOps is all about. In the definition from PMI, they say, what does it take a disciplined team to deliver great product, to deliver great software? It requires discipline. It requires discipline to do things that are good for you that you may not normally choose. And given that, the PMI's definition reads, as you can see on the screen here, disciplined DevOps from their world, PMI's world of discipline agile. If you weren't already aware, PMI bought discipline agile. So PMI's definition here says disciplined DevOps is the streamlining of IT solution development and IT operations activities, along with supporting enterprise IT activities such as security and data management to provide more effective outcomes to an organization. Now, more about that as we go through this content. But what I really want you to take away from the image on the screen is the cycle of life that should be happening. There's going to obviously be some coding and testing and design and planning, but at the same time, we want to remember, we're going to deploy, we're going to operate, we are going to support, and we're going to monitor. And all of these form an infinite loop. It never ends. And that's why we have the infinite loop as the logo for DevOps. It makes sense, right? So it's all about integrating, automating, measuring the never-ending cycle. We want new products faster. Think about it. We want new features, security updates, bug fixes. We want to deploy new products quickly, features quickly. Think about the likes of Amazon. Think about the likes of Spotify. They're always on the move, developing, putting into production, developing, fixing bugs, being aware of security, getting data back, putting it into the pipeline. That's really what this is about. It's the never-ending cycle. So we have old code, we have pending code, we have new products, new features. We need to automate as much as possible. If we can automate everything, let's do it. But realistically speaking, you can't really automate everything. There's going to be some human intervention, but DevOps seeks to automate as much as possible. The idea is to get our customers working streams of product frequently, things that are going to delight them. In DevOps, the development and operations team collaborate. The developers may also be responsible for operations, or there could be two separate teams that have open communication. Regardless of the particular configuration, teams should be made to feel ownership of the entire software lifecycle. Let's take a look at this brilliant table from the GAO Agile document that's out there from the federal government of all people. But here we can see these principles exist in DevOps. Automation of processes. DevOps teams try to release software as frequently as possible, which requires automated testing and development, continuous integration, and continuous delivery. Standardized environment. Many issues of interoperability arise when new code doesn't work in the operations environment. Since the DevOps team develops the software and troubleshoots bugs in the operations environment, the developers become more familiar with this environment. Standardizing the environment helps with these interoperability issues. What about microservices? In order to push frequent releases, the DevOps team uses an architecture comprised of microservices, small, decoupled components that ideally work independently of the other software components. Monitoring. Since DevOps teams are responsible for support and operations, the team should be monitoring the operational software. The frequent releases can help the team isolate and pinpoint which software update has an issue. It's all about being smart and intelligent in development and operations. The driving force of DevOps is to create frequent small releases. In order to do this, DevOps teams frequently adopt several of the principles. Let's talk about tool chains. Now, as DevOps is intended to be a cross-functional mode of working, those who practice the methodology use different sets of tools referred to as tool chains rather than a single one. And that's why when someone says, I'm a DevOps engineer, they don't mean they use a particular code. DevOps isn't about coding. It isn't all about tools, but these tool chains are expected to fit into one or more of the following categories, as you can see on the screen. DevOps is many things: coding, code development and review, building continuous integration tools, build status, testing, packaging, releasing, configuring, and monitoring applications. And that's why when you typically look at the enormity of tools that surround DevOps, you get a picture like this from Inland Software. You see that in the planning aspect, we could have things like Microsoft Office, Project, Enterprise Architect. But when you take a look at the build and the operate, you begin to see other things like Jira, like GitHub is probably one of the most popular ones, Jenkins as well. So there's a confluence of tools that could be used in different aspects, different parts of DevOps. So DevOps is many things. And when we think about tool chains, we're not thinking about just one tool, we're thinking about a confluence of them. Let's talk about the relationships of DevOps to other approaches. So first of all, the Toyota Production System, also known under the acronym TPS, was an inspiration for lean thinking with its focus on continuous improvement and Kaizen. And that is part of the essence of DevOps. The next one is DevSecOps. Now, this is throwing in the piece about security. So you remember the definition that I showed you a while back from PMI's disciplined DevOps. Remember, towards the end of the definition, you saw a mention of security and you saw a mention of data. Well, that's what we're talking about, right? There's a relationship between these concepts. DevSecOps is an augmentation of DevOps to allow for security practices to be integrated into the DevOps approach. Contrary to a traditional centralized security team model, each delivery team is empowered to factor in the correct security controls into their software delivery. This is key for how business is developing. Next one on the screen you see is ArcOps. This presents an extension of DevOps, starting from software architecture artifacts instead of source code for operation deployment. ArcOps states that architectural models are first-class entities in software development, deployment, and operations. Next on the screen should be a familiar one to you. Those of you from the project management world, it's CI/CD, continuous integration, continuous delivery, or we could say continuous deployment. This is used as three prongs in which we are building, we're testing, but we're also automating. So DevOps teams can ship code changes faster and more reliably. When referring to CI/CD, the CD being referenced is usually continuous delivery, not continuous deployment. Continuous delivery and other CI/CD processes are focused on automating software delivery tasks, while DevOps also focuses on the organizational change to support great collaboration between the many functions involved. It's all about collaboration. Both share a common background in Agile methods and lean thinking. The final one that we have here is DataOps, and all this refers to is the application of continuous delivery and DevOps to data analytics. It's been termed DataOps. DataOps seeks to integrate data engineering, data integration, data quality, data security, data privacy with operations. Now you've got a very robust idea about what DevOps is. Let's wind down this conversation. Building a DevOps culture. Organizational culture has a strong predictor of success. If the culture does not espouse collaboration and it's us versus them, then DevOps won't get very far. Cultural practices are important. Things such as information flow, collaboration, shared responsibilities, learning from failures and new ideas are central to DevOps. Team building and other employee engagement activities are often used to create an environment. Remember, even though it sounds all technical, it's really humans at the core. So you think about the 5 stages of team development and you think about how you can get your development team and your operations team to work as one well-oiled interdependent unit. DevOps could be looked at as a service approach. And this allows developers and operations teams to take greater control of the applications and infrastructure without hindering speed. It also transfers the onus of owning a problem onto the development team, making them more careful in their stride. So it's not just tossing code over the wall and then having to clean up the mess after someone else, that is. In DevOps, we see ourselves as one. DevOps, one. The summary is this: project managers should learn about this. Now, you might not be taking a professional exam, but still, you should learn about DevOps so you can speak the language. In fact, before this is done, we're going to be bringing on one of our experts to talk about technical project management. So don't get scared when you hear people talking about GitHub or Jenkins or any of the tools you see on the screen that are outside your zone of comfort. As a project manager, I highly advise you to pick up tools and methods and ideas and abilities that might be a little bit outside your comfort zone and eventually far outside your comfort zone, because whether you like it or not, DevOps is here to stay, right? One of the final things I would say is the DevOps culture is a choice of tools on a team by team basis. It's not pushing one set of tools, but it's allowing the team make its own decisions about which tools to use. While several tools exist, there's no one size fits all tool. However, developers should consider the need to integrate with monitoring tools used by the operations team to detect performance issues as quickly as possible. Developers should also integrate with security tools from operations in order to protect all involved resources. So one more time, we're going to hear from our professional. His name is Paul. Paul has been on this channel before to share technical project management. I would advise you to look for all the other parts of this conversation, but let's hear what Paul has to say about being a technical project manager. It is such an important piece of the puzzle. Over to Paul.
Hi, my name is Paul Lewis. I am a technical project manager. I've had 20 years of experience doing this. I got started right out of college fixing computers and sharpening my technical abilities to keep on moving forward in my career. I continually keep my skills up to date by doing a lot of outside project work, usually in a technical capacity. Try to fix computers, make sure I stay up to date on all the latest operating system technologies, cloud computing, and that sort of thing. I'm a Six Sigma Green Belt, and I have been a Scrum Master. I was previously a Scrum Master, and now currently I am a delivery manager within an Agile program, which is part of the leadership of the actual program that the Scrum teams are built out of. So what is the difference between an IT technical infrastructure PM and a traditional project manager is really what you're working on. You're expected to have a working knowledge of the subject matter that you're working on, whether it be server technology, virtualized technology, Kafka, all the different types of deployment software that's coming out now, cloud computing. You're supposed to at least have some technical knowledge of the project you're delivering. You're also expected to be able to fill in for some of the engineers when they're not present. Sometimes they get called enough on other different projects. You need to be able to fill in to be able to do some of the work that they would do, not necessarily down to the nitty gritty, like, building firewalls and stuff like that, but at least be able to have a working knowledge of how to do their job. So a meeting has to happen. A customer needs some technical input. You should be able to provide some of that. Now, granted, you're not expected to be the expert because that's what the engineers are for, and not necessarily have to do the work. It's helpful if you can do the work. That's really ideal for what they're looking for in this capacity. But if it's not, then you just do what you can. You need to be able to create high-level designs in Visio, be able to create the different design documentation at least the high level, not down to the nitty-gritty. As discussions, especially initial discussions, you don't necessarily have to have an engineer there. Usually their time is pretty precious. So what you would want to do is make sure that you have a working knowledge to be able to do the high level design. And as the discussions go deeper, you need to be able to facilitate that discussion to be able to quote the time and materials that would take to complete the job.
And there you have it, my friends. I hope you enjoyed this first look at what Paul has to offer. I would encourage you to look for the links below this so that you can get the full series. There are about 7 videos where Paul walks us through what it means to be a technical project manager with emphasis in the world of Agile and Scrum. I hope you found this to be useful. If there are any other buzzwords from the technical project management space that you would like me to define for you, I would appreciate you put in a chat below, put in a comment, and let me know what else you would like us to feature on this channel. Thank you very much. I wish you all the very best in your project management. Don't stop learning. And remember, hey, pick up the GAO Agile Guide. I'm going to put that somewhere in the links below. It's from the federal government. It's free. It's a great guide. You can learn all sorts of stuff about Agile in there. Take care and talk to you soon.